Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. You have also information here about online seminars that I teach. I teach seminars for PFM, IFM, and LTAM at Illinois State University, and information about the study manuals for PFM, IFM, and LTAM that I wrote. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support those students, please go to smarturl.it/help ISU actuary. Here's problem number 4 from the multiple choice section of first exam LTAM ever, given in October 2018. For a 3-state Markov chain model, you are given the annual transition probability matrix is as given, and what you see is that the probability of transition from state 1 to state 1 is 0.2, from state 1 to state 2 is 0.3, from state 1 to state 3 is 0.5, from state 2 to state 1 is 0.1, from state 2 to state 2 is 0.6, from state 2 to state 3 is 0.3, and from state 3 to state 1 is 0.9, from state 3 to state 2 is 0.1, and from state 3 to state 3 is 0. The process is in state 1 at the start of year 1. Transitions occur only at the end of the year. Calculate the probability that the process will be in state 1 after the transition at the end of year 3 without having transitioned to state 2. And here's the solution. What we do basically is just write out all the possible ways that what we want can happen. So all the possible series of transitions that start in state 1 and end in state 1 without having transitioned to state 2 are as you see them. Now note that it is not possible to go from state 3 to state 3. So that eliminates some possibilities. So if we start in state 1, go to state 1, and then state 1 and state 1, obviously we end up in state 1 and we didn't go through state 2. If we go from state 1 to state 1, then to state 3, and then to state 1, we have exactly also what we want. We end up in state 1 and didn't go through state 2. Note that we can't have state 1 going to state 3 and then to state 3 again, because going from state 3 to state 3 is impossible. So we could also go from state 1 to state 3, but then back to state 1 and to state 1. These are 3 mutually exclusive events, and their probabilities are, for the first one, P11 times P11 times P11, because it's a homogeneous Markov process. The transition probabilities are the same at every time, and that's 0.008. For the second one, it's P11 times P13 times P31, and the probability of that is 0.2 times 0.5 times 0.9. You just read this from the matrix, and that's 0.09. And then for the third one, it's P13 times P31 times P11, and the probability, and that product is 0.5 times 0.9 times 0.2, and that's also 0.09. And 3 mutually exclusive outcomes that give us exactly what we want, so the total probability is the sum of the 3, and that's 0.008 plus 0.09 plus 0.09, and the total is 0.188, which is answer D. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.